Welcome to the second part of 9.5. We're going to continue this process of graphing quadratic functions. So again, now you saw the first one, I want you to pause the video and find the vertex of my function. Go ahead. All right, so if you did it, remember the first thing we do is the x value, and the x value is negative b over 2a. Now, our b in this case is only 2, but our a is negative 1, because that's a negative 1 hanging out here. Even though I can't see the 1, that's really negative 1. And that's going to give me negative 2 over negative 2. Oh, x is 1. Well, that's nice. We like that. We plug that back in. I get negative 1 squared, negative times the quantity, 1 squared. And then I have 2 times 1. So that's going to give me negative 1 plus 2 minus 2, or in other words, negative 1. So my vertex is the point 1, negative 1. Okay. So hopefully you got that. You're feeling comfortable. Maybe there's a little arithmetic mistake. That's okay. We'll try to work out those little flaws. But I want you to jump to the next question. Can you find the y-intercept of the function? And remember, how do you find it? Well, it goes back to setting x equal to 0, so I'm just looking for f of 0. That's nice. I can plug that in. And again, notice this and this are both 0, so I'm just left with negative 2. So my point is 0, negative 2. I really like that one. Okay, so I got 2 points. Let's now try and find the x-intercepts. Go ahead and pause the video, find the x-intercepts. Now, as you did this, we set it equal to 0. You could have divided everything by negative 1 if you really wanted to. That's perfectly fine. I'm going to use the quadratic formula personally, partly because I know what's going to happen. So my b is 2, so I got negative 2, square root 2 squared minus 4, and then minus 1, and minus 2, because that's a and that's c, and then a minus 1 down here. Well, if you start doing some plug and chugging, this is going to get 4. This 3 negative is still negative 8, and I got negative 2. But wait a second. What's going on? What's the problem right here? That's right. Negative 4, square root of a negative is not real. So that means that there are no x-intercepts. Uh-oh. Well, we actually could have had a hint about this. Here's why. So I'm just going to rewind this real quick and point something out. Notice, what was the y value of my vertex? It's negative. And in which direction does my vertex open? Opens down. If this opens down, that means it's just going to go downward. And if it's starting at a negative number already, it's just going to go further down. It's not going to go up to x equals 0. So we kind of had that warning coming. We just kind of ignored it, but it was there in our face. There's no x-intercepts. Well, I only got 2 points, so we need more points. How are we going to get more points? And I'm not saying points for the exam. I mean points for this graph. So what we're going to do is we can literally just guess. We can say, okay, I want f of negative 1. Let's just pick another x value. Because we've used 0 and we've got 1, so let's try when f is negative 1. And literally just do the number crunching. That's all you're going to do is pick 2 x's, crunch the numbers, plug them in. Well, negative 1, I get negative 1 squared, which is again negative 1 minus 2 minus 2. So that's minus 5. Okay. And so I get negative 1, negative 5. What about 2? Pause the video, find f of 2. Well, hopefully you plugged it in. Just did the plug and chug, which gives me this, which you multiplied out is negative 4. Those go away and get, it should be actually negative 4. So that's a little off right there. Well, actually, this should be a 4, and that is negative 2. So this should be a 4, because that should be negative 4 plus 4. That's a typo, my fault. But that is the correct answer. It says negative 2. Okay, so I get the point 2, negative 2. Now again, we start off with our nice list of points. So can you graph, I just collected them all together. can you graph these 4 points? Hopefully, excuse me, you can. And notice, like I said before, these are what these 3 points. Now, if I'd made that mistake in the last point when I made a typo, if you make a bad mistake, you'll notice that your point's going to be way off. If your point's way off, go back and recalculate it. Don't just bang your head trying to fit a square peg into a round hole. Now we can connect these dots and we get a nice shaped parabola going downward. So all of this is just to give us a few points to then help us graph it. All right, let's try example number 3. So how could you find first the vertex of this graph? Go ahead and find it. Go. Well, welcome back. As a reminder, the x value is negative b over 2a. If you forgot that, pause the video and quickly do it. Otherwise, we can plug in, so x, notice a is 1 and b is negative 4 in my case. So I got negative 4, which is positive 4 over 2 or 2. Now I'm taking a moment, I'm going to pause and just make a comment. Notice I keep writing this in because I'm trying to be explicit. That's actually not because I'm trying to show you all my steps. It's because I know that you make fewer mistakes when you try to do that. It doesn't save you enough time to really be worth your time to be trying to skip it. Now if you plug in 2, we end up with 4 minus 8 plus 4 or 0. So 2, 0. That's my point. That'll come back and be something to think about later. So let's find the y-intercept. Well, the y-intercept, remember x is equal to 0. So go ahead and, if you didn't find it, go ahead and pause the video and find this. And I wrote f instead of g. That's just me. So if you plug that in, you get 0, which 0 minus 0 plus 4 or 4, so I get 0, 4 as my nice y-intercept. So let's move on to the third thing. Can you find the x-intercepts of my function? Go ahead. Well, as a reminder, that means y is 0, so boom, we got this. Now you can use the quadratic formula and all that other stuff for factoring, and this turns out to be x minus 2 times x minus 2. These are the same, so I just have x minus 2 is equal to 0, so I only, wait a second, isn't that a point I already had just a minute ago? Notice I already had the point right here because x is equal to 0. So my vertex was already going to be the x-intercept. So again, I only have 2 points, so we need more points. So I want you to pause the video and I want you to find 2 more points, 2 more x values you can plug in and find the points for them. Go ahead. Well, welcome. I picked the points, I picked 1, trying to pick small numbers. And when I do my number crunching, notice this minus 4 and plus 4 go away, so I end up with just plus 1. So I got 0.11. And for 3 squared minus 4, 3 plus 4, that's 9 minus 12 plus 4. Oh, wait, that's 1 again. So I have 3, 1. So notice this is again okay. The y values are the same. It's not the same x values. That would be a problem. So let's take that and let's graph it now. Well, we have our little table. So graph your 4 points and play connect the dots. Go ahead. Well, as you did that, you end up with the points right there. And again, we can connect them. And we get this nice, pretty parabola. So I'm hoping you guys are feeling pretty confident at this point in time. There's lots of different possibilities of how things will happen. But I got one last for you. I want you to go ahead and pause the video and work through this problem. Find the vertex, find the y-intercept, and find the x-intercept, and then graph it. Go ahead. Well, hopefully you finished it. You're coming back to check. So vertex, use the vertex form. Our B is 6, and A is 3, so plug those in. Negative 6 over 6, I get negative 1. Plug that back into the equation, I get 3 times negative 1 squared plus 6 times negative 1, which is 3 minus 6 plus 4. Oh, so that's minus 2. Okay, so I got point negative 1, negative 2. The y-intercept, remember, is when x is equal to 0, so we plug that in. And then we just plug that in the equation, and we get the point 0, 1. So I now have 2 points. I need more points. So the x-intercept, as a reminder, was when y was equal to 0. So we plug in 0 for f of x. Now to solve this, factoring isn't going to work. You're going to have to use the quadratic formula. So if I take the quadratic formula, I already talked about A being 3, B is 6, and C is 1. So we plug those in according to all the spots and then start chugging our numbers. Well, that's going to give me minus 6, 36, minus 12, and over all that over 6. My square root here, oh, that's going to be the square root of 2 times the square root of 6 because there's a 4 that goes in there. I can reduce this because I can pull a 2 out of both them. And I get 3, negative 3, plus or minus square root of 6 over 11. That's nice. But what are we going to do? Because I'm looking at this going, I have 2 points here. I have x equals negative 3 plus the square root of 6 and negative 3 minus the square root of 6, both of them over 3. So I got 2 points, but I don't really know where these points are. Well, you can use your calculator to kind of estimate, approximate to know about where x values are, but you already know exactly where the y values. So it kind of helps just label where they are. So to show you that, I'm just going to take my graph, and this point right here is negative 3 minus the square root of 6 over 3. So it's kind of ugly the way my graph turned out. But this is this bottom x value. This one right here that's pretty close to 0 is this other square root x value for intercepts. The vertex is this thing down here, and then the 0, 1 is that point. So again, we can connect the dots, and you get a parabola that looks kind of like that. So this whole process is just a systematic way to come up with several points that help us know the general behavior of the graphs and help us graph them. Good luck. Please let me know what questions you have, and good luck in preparation for the final.